Okay, so let's take a minute and do a quick tutorial on how to use PLC Fiddle. Now, this is not going to cover every instruction that PLC Fiddle has. There are many, so we have the standard contacts, so normally open, normally closed, and then I'm not sure what that is. Um, Coils, so this is a standard coil, so an if-else, right? This is a latch or an OTL. This is an unlatch or an OTU. We have various math instructions, various comparison instructions. We've got timers, and we also have a few sort of higher level operations here. We can add rungs to the program, we can add branches to the program, and we can also delete any elements that we wish to delete. So this is just the standard program that if you go on to PLC Fiddle, you will find running. And this is the motor operation circuit that we talked about with the start and stop button early on in the first couple of lectures. So if I were to press the start button, the motor will begin to run. So the value of motor is now on. If I turn the start button off, the motor will stay on because we are sealed in by the motor. So what that means is that the logic of this circuit is if start or motor and not stop, motor should be true. And that's exactly what we have here. So if we press the stop button, the motor will stop. And we can turn the start button back to the off state and the motor remains stopped. So we can see that this PLC fiddle works just as we would expect an Allen Bradley PLC to work. The main difference that you'll see in this environment is the scanning speed is much slower. An Allen Bradley PLC is scanning once every 40 microseconds, depending on the size of your program. This is scanning once every, roughly half second to 300 milliseconds. So much slower scanning speed. So let's build a quick little example program with some variables. Variables are the same things as tags. Doesn't matter which terminology you use, but typically in PLCs, variables are referred to as tags. However, in this environment, they refer to them as variables. So first thing we'll do, we can delete elements one at a time. Notice when I drug the element into the trash turns blue in its outline. That's how you know that when you let go, it will disappear. We can also drag the entire rung and delete an entire rung. So now we have an environment in which we can build a new program. Now let's quickly clear off these tags so we can create new ones. All right. So what we're going to do is we're going to build a program. And this program is not going to be extremely useful. It's just as an example to demonstrate how to use PLC Fiddle. But what this program is going to do is as long as a button is pressed, we are going to count up continuously. So we're going to have some value, we'll call it sum. And that's where we're going to store our count. And each scan of the PLC, as long as the button is pressed, we're going to count up by 1. Now, there's no way to do immediate values in PLC Fiddle, so to make the number 1, we'll have to create a variable or a tag. We'll call it 1. And we're going to store the value 1 in that tag. And now we're going to create our button. Now, this button does not need to be a number, right? It needs to be a Boolean. Now, let's make our logic. So we said as long as the button is pressed, we are going to count up by 1. So we're going to take whatever is stored in sum, we're going to add 1 to it, and we're going to store it back in sum. So this logic, as long as the button is pressed, will take sum, add 1, store it in sum, each scan of the PLC. So when I change the value that is stored in the tag button to true or on instead of off, what we should see is this value right here stored in sum begin to increment by 1 each scan of the PLC. Now let's see if it works. Yep. So now each time the PLC scans this program, we are adding 1 as long as the button is pressed. So if I turn the button off, we should stop counting. And we do. So our program works. So this is just a simple example program of how to use PLC Fiddle to test out logic and create programs that you could then go and test out on other ladder logic executing systems like Allen Bradley or Siemens PLCs.